I love tinkering with my guns. I do gunsmithing as a hobby. Hell, I enjoy gunsmithing as much as I enjoy shooting my guns. I like to customize my guns and make them my own while getting as much performance out of them as possible. I don't really do this for any practical reason other than it's fun for me to modify them and it makes them more fun to shoot. I have several pistols with compensators that I really enjoy, and I wanted to try some barrel porting to see how I liked it. The cool thing about porting is that it only requires some pretty basic machining operations. I have a decent amount of machining experience, I have access to a mill, and my dad is a retired machinist who knows way more about machining than me, so I figured I would go ahead and port my first pistol myself with my dad's help. First, I had to choose the pistol I wanted to port. This pistol couldn't be one that already had a compensator on it, and it obviously couldn't be one that I run suppressed. I had several pistols that would have worked, but I chose to start with my favorite striker-fired pistol, the CZ P-10F. In this video, I will give some insight as to why I chose the porting layout I did and how I selected the port size and location. I recently published a video on recoil spring tuning that includes a discussion about how compensators and porting affect recoil spring weight, so check that out for some supplementary information. I filmed the whole machining process and provided a voiceover to explain what I was doing if that interests you. Then I will show some shooting footage and compare the performance before and after porting. As always, timestamps will be provided so you can skip around as you please. I will link to some other videos of mine in the description on this pistol, as well as the recoil spring tuning video I just mentioned. I started looking around at some barrel porting services from machine shops to see what common layouts there are, how many ports, the port size, and things of that nature for 9mm pistols. V-shape porting is very common and has some packaging advantages to the straight out the top porting, but I don't have access to a tilting vise yet, and I wanted to keep the machining as simple as possible for this first one, so I was going to keep my ports pointing straight up through the top of the slide. One company that offers porting on the Shadow 2 Wicked Arms has a nice, simple, inline, straight out the top design. Another one I kept seeing on CZ forums was grenade porting from United Firearms. I figured a straight row of holes in the barrel and a simple slot in the slide would be the best to start with. After some internet sleuthing, it seemed that 4 ports around 5/32 to 3/16 of an inch in diameter were pretty common for 4 to 5 inch 9mm barrels. Let's get into some basic considerations regarding porting location. First and foremost, the purpose of porting is to push the muzzle of the firearm straight down to mitigate muzzle flip. So this is where ports straight out the top will be better than V ports. V ports are going to have a resultant force vector that has a component in the sideways direction, which will be wasting some energy that could be used to force the barrel downward. We want our ports to be as close to the end of the barrel as possible. That way the force is acting on the barrel with the longest moment arm from the pivot point of the pistol in our hand, giving it a better mechanical advantage. This is where V ports have an advantage because they can flank the front sight and be pushed further forward. Another possible advantage of V-ports is that they won't foul up your fiber optic or night sight if you're using your irons. I wanted to retain my front sight, not have to mill a new dovetail or slot for it, so that means my ports needed to go behind that. One other thing I was concerned with was taking away from where the barrel locks up into the slide. I didn't want to loosen up the barrel to slide fit as this would affect accuracy. Even if I didn't care about losing my front sight, if I pushed the slot further forward, I would have cut into that barrel to slide lockup area. I've seen 1911s and 2011s with bull barrels that were machined for a chunk port right up against the muzzle, and it made me wonder if it affected the barrel lockup at all, or if the barrel lockup area would wear really quickly and become loose due to lack of surface contact area. I picked a nice round number and made my slot 1 inch long and evenly spaced 4 holes in it. I needed to figure out if I should start with the 5/32 or 3/16 inch holes I was commonly seeing, and the conclusion I came to is that I want to prioritize gas velocity. We want to maximize the energy of the gases leaving the barrel ports straight up. That energy is going to create an equal and opposite impulse that shoves the muzzle of the firearm down. The more we maximize the energy of the gases leaving, the more we maximize the effect on muzzle flip. Energy is proportional to mass and velocity squared. So velocity has more of an impact on the energy of a moving body or substance than its mass does. Think about putting your thumb over a garden hose end. What happens? You make the opening smaller, the water velocity increases, pressure behind your thumb increases, and the fluid stream shoots further. Smaller diameter ports will allow higher pressure to be maintained in the barrel, and gas will be coming out at a higher velocity. So I decided to start with the smaller port size that I was commonly seeing, 5/32 of an inch in diameter. Honestly, you could probably arbitrarily punch holes in the front of your barrel and have it make a difference in muzzle flip, but to optimize the best port size and location as it relates to the barrel length, bore diameter, bullet velocity, gas pressure, volume, powder burn rate, etc. would be very difficult and time consuming and require some serious knowledge and experience. Ideally, someone could run computational fluid dynamics simulations of a bunch of port sizes and layouts and confirm those results by testing multiple barrels with different porting in the same gun with the same ammo. I don't have that luxury, so I'm kind of winging it. I wonder how many companies that offer porting get into testing like that. I'm sure if you were to talk to certain very experienced competition shooters that have run a lot of ported guns, they would be able to tell you, oh yeah, for this 9mm load in this barrel length, you want X number of ports of Y diameter. Let's look at the machining process, shall we? There were a few steps I didn't film before this. I swept in the vise to make sure the jaws were parallel with the long axis travel. I then used the edge finder to zero my y-axis off the back solid jaw of the vise, traveled half the width of my slide and zeroed my y-axis to the center of the slide and locked it in place. In this clip, I am using the edge finder to index off the front of the slide and zero my x-axis. I figured it would be a good idea to throw some tape on my optic lenses to protect them. I already moved to my desired location for the front of the slot, just kissed it with the drill bit and then double checked I was in the right spot with calipers. I was happy with that and proceeded to drill the 1/4-inch hole that was the front of the slot, pecking away at the hole nice and easy and adding some drops of lube in between. I was very careful when I knew I was about to break through to minimize burrs I would have to clean up on the underside of the slide. Moving back and drilling the hole that creates the rear of the slot. Then I took the chuck out and grabbed a 1/4-inch end mill and installed it with a collet, plunged that into the front hole and cut the slot all the way back to the rear hole. After that, I installed a 3/8-inch 90-degree end mill and put a 45-degree chamfer on the slot's top edge. I made contact with the top edge of the slot, then lowered it 15 thousandths more. Then I ran the mill over the length of the slot to chamfer the whole thing. With the slot done, now comes drilling the barrel. I grabbed the barrel in a vise on some parallel bars, then squared the flat chamber area up to the mill deck with a machinist square. This ensured I would be drilling directly through the top. I double checked this with another square and had my dad check it as well. Then I used the edge finder to zero my y-axis in the center of the barrel. Then indexed the x-axis and zeroed it off the muzzle. I used a center drill to just kiss the barrel in the 4-hole locations. Took some measurements to make sure I was happy with the placement. You can't see it, but I also scribed 2 very faint lines in the barrel where the ends of the slots were, so I could make sure my hole pattern was centered in the length of the slot. I then center drilled the holes. You got to center drill when starting a hole on a rounded surface so the drill bit doesn't walk on you. I then changed to my 5/32 drill bit and finished all 4 holes. Once again, you can see me gently pecking away at it and adding some lube. I slowed down when I was about to break through to minimize burrs on the bottom side of the hole inside the barrel. Here I'm just carefully twisting a countersink by hand to deburr the top edges of the holes. I then rolled up some 600 grit sandpaper on a small rod and ran it over the underside of the holes in the bore. This did a good job of knocking the burrs down, and some FMJ 9mm will do the rest of the deburring for me when I take it to the range. So I actually think the milled area looks kind of cool in silver, but I am going to go ahead and see if this material will take cold blue, if it's a carbon steel versus a stainless. Same thing on the barrel. We'll just see if these ports are going to take cold blue, and they are. Slide in the barrel both took cold blue very nicely, so that's looking really well finished. Last thing I'll do is give those little places a blessing of oil so they can sit and think about what they've done. And man, this porting job came out beautifully. I'm quite pleased with myself. That doesn't happen often. Here is slow motion footage of 4 separate shots of the pistol before I did the barrel porting. This is a still of the last shot right as the shot was being fired before the muzzle started tilting up. And here is the maximum angle of muzzle tilt. I took both of these pictures, overlaid them, and put them into ImageJ, a image processing and analyzing software, and measured the muzzle flip angle at 13.1 degrees. Here is slow motion footage of 6 separate shots after the barrel porting. Muzzle angle right as the shot was fired, and maximum angle of muzzle flip. Once again, overlaying the images, and measured a muzzle flip angle of 9 degrees. I am really pleased with the performance of these ports. I do need to make it clear that I was not using the same ammo between the non-ported and ported tests. I used up the last of a case of ammo when capturing the non-ported footage. That was 115 grain Blazer brass. The ported footage was using Winchester 115 grain. They should be really close, and the difference in advertised muzzle velocity is only 40 feet per second, but they're not the same ammo. It would have been best to keep the ammo the same, obviously, but I don't think this completely negates my results. There is a significant reduction in muzzle flip, about 30% between the measured values. Qualitatively, in my hands, when shooting, there was also a big difference in recoil feel. This porting did not necessitate recoil spring changes either. I'm happy with the ejection distance. Well, obviously, this went well. I will be porting more pistols. I'm already working on modeling and drawing up some inline port and chunk port designs for different barrel lengths based on the performance of this porting job. I think The ratio of total port cross-sectional area to gas volume, which of course would be proportional to barrel length, is about right. I will try to keep this ratio the same as I port pistols with varying barrel lengths. My CZ P-10 is next, then likely my Springfield Hellcat, maybe my M&P 2.0, maybe my Shadow 2, maybe my HK P-30. More videos to come. As always, I hope you found this interesting and or cool. Thanks so much for watching.